Well, guys, today we're talking about something called the limiting reactant. Now, in order to understand this, the first thing we want to do is watch a short clip.
Let's take a look.
So here I am in my garage with one thing I love to do, and that's ride bikes. Now what I've got here is I've got three of my sort of bikey things. And if you know, there's really a formula. The formula is this: 2 wheels plus 1 frame makes 1 bicycle. So here's the problem. How many bikes can I make with these frames and these wheels? Well, let's count them. Frames, 1, 2, 3. 3. That's good, 3. Wheels. Now I got some wheels here, don't I? I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 wheels and 3 frames. How many bikes can I make? So as you can see, I made 3 bikes, but I have 1 wheel left over. So the wheels were the excess reagent, and the frames were the limiting reagent.
So what's up? You got bikes, you got frames, you got wheels. What's going on?
Anytime you try and put something together, when you run out of that something, you can't put anything more together. And this
All right,
works.
so in our packets, we're going to define a couple of terms. So in letter A there, it says a blank is the reactant that controls. There's a lot of words here, Mr. Dimitri. What does that mean?
A limiting reactant is whatever reactant gets used up. So in the example of our bike, what would that be?
We ran out of frames first.
Yeah, so that would be the limiting reactant, or reagent we sometimes call it, would be the frames.
Okay, so you're the one you run out of first is the limiting reactant, or letter A here in our packet. And letter B is going to be the wheels. We had a lot of extra wheels, so that's called the
Excess reactant.
excess reactant.
And it kind of makes sense. Whatever you have extra of that you don't use is your excess.
So you don't always have the perfect amount. And it's kind of like this. You kind of want to ask the question, if I've got 15 eggs, how many chocolate chip cookies can I make? Okay, but maybe I've also only got 1 cup of flour. Well, then actually the eggs, I think there's 2 cups for like 3 cups of flour, or two eggs for 3 cups of flour, whatever it is. If I only got 1 cup of flour, I can't make many cookies.
Yeah.
So I've got to figure out how many cookies I can make based upon how much flour I have. Or if we use like an airplane analogy that's in the packet.
Well, yeah, we've all experienced this, especially now where they overbook, right?
Yeah.
So if they're overbooking someone and the plane only has, 250 seats?
Yeah.
Guess how many people are traveling?
250.
250 people. It doesn't matter if there's 300 people or 500
So
people.
the limiting reactant there would be the number of seats.
Number of seats.
Not the number of people.
And the people would be the example of your
Yeah.
excess.
But let's put this in the chemical world. So
Yeah.
a first example, what do we got going here?
Well, let's just take a really basic example. C plus O2 goes to CO2. And let me remind you that even though there's nothing in front of each of these, aren't those coefficients 1s? And all of our recipes, is a code word of saying our reactions, they're written in terms of moles. So the way of saying this is 1 mole of carbon,
Plus
reacted
1
with
mole
of
makes
oxygen.
1 mole.
1 mole.
That's an easy one. But let's say, like we have the bracket, 5 moles of carbon and 10 moles, so they show up to the dance, so to speak, and 10 moles of oxygen show up to the dance. How many moles of CO2 can I make? Now, this doesn't take a rocket scientist to figure out, since the ratio is 1 to 1 to 1. And this is like, it's obvious, right?
Now, I want to, this is really important because sometimes we make this terrible error. I have a recipe, and let's say you've done cooking at home. If you have the recipe, does that mean you have the ingredients?
No.
Just having the recipe doesn't mean you have the ingredients. So what sometimes we'll do is we'll look at the recipe and go, well, I guess I have this amount of this and this amount of this. No, this is the recipe. We need 1 of this and 1 of this. This is what we have.
That's what's in the cupboard. Yeah.
That's what's in the cupboard.
So how many cookies can I make? If I got five cups of flour and 10 eggs, I don't know what they call it is, I can only make what?
By the way, your cookies are made up of egg and flour alone. Those are delicious. I can only imagine.
That's very tasty. That's going to simply, we can do this in our head, guys, but it's 5, right? Because I'm going to run out of carbon first. The oxygen I've got left over. So let's actually label these.
But wait, I have 10 moles of oxygen.
So, but you're going to use up 5 of them.
So what? Yeah, the reality is I can have a billion of this.
Yeah.
If I want to make CO2, I have a billion of this and 1 of this.
Yeah.
When this gets used up, we're done.
So let's label. First of all, we would call the carbon the LR, the limiting reactant, which stands, it's the one you run out of first, and then the oxygen is the excess, or the ER. Don't confuse that with emergency room. Or you call it XR. I always call it
It's
ER.
fun. It's so much fun to write
XR,
XR.
whatever. That's the excess reactant, and that's it. That's how you do it when it's mole to mole. Life changes though, because things we don't have a mole meter. We've got a gramometer, if you will. We have something that measures grams. So let's look at that next. So here we have this problem. We've got a simple reaction, hydrogen plus oxygen makes water. But remember, whenever you do a stoichiometry problem, you have to start with a what?
Balance equation.
All right, balanced equation. I've got 2 hydrogens, I'm happy. I've got 2 hydrogens, I'm happy. I've got 2 oxygens, I'm not happy. I've got to fix my water, or my oxygens, by changing the number in the water, but that messes up my O's. No, it messes up my H's, so it's 2 H's plus 1 O makes 2 H2O's. Now, you're going to do a problem now. Watch this. We're going to start with 12 grams of hydrogen.
12.0 or just 12?
12.0 grams. And 25.0 grams of oxygen. So the question we want to ask is, how much water can you make? Now you might say, well, it's 12 is the smaller number, so that's the one I'm going to run. No. And this is going to be the same ratio. You can't do this because you have to do a stoichiometric, if I like to call it, line. So we want to do, actually we have to do 2 lines. This is going to be a little bit tedious. So we're going to start with, we're going to convert grams of hydrogen to grams of water. All right, and then we're going to convert grams of oxygen to grams of water. And it turns out the lowest answer wins. Because you think about it, like you go back to like the cookie analogy. If I've got 2 eggs, and that can make me 24 cookies, let's say, and I've got 28 cups of flour, and that can make me 475 cookies or whatever, I can only make the lower number. All right, so we have to do the math completely through. So start out here, right? 12.0 grams of hydrogen. So 12, we're just going to do gram to gram, gram to moles, moles to moles, moles to grams. You've done this before. Now we're going to, let's just for the sake of time, just round this. We're going to say 2 grams of hydrogen, that molar mass of hydrogen is equal to 1 mole of hydrogen, right? And then we're going to do the mole to mole ratio, right? What can we cancel, Mr. Dimitrich?
Well, this cancels out my grams.
Yeah. And now we're going to go from moles to moles, and that's going to be, 2 to 2. We're going over here. So 2 to 2. So to put 2 moles of hydrogen on the bottom and 2 moles of water on the top. And what can we cancel out? And then we're going to do it again.
Now we want to go from moles to grams, right?
Moles to grams. So we'll put moles of water here. 1 mole of water. These 2's only came up when we're in the stoichiometric ratio. And then there's 18 grams of water, 16 for oxygen and 2 for hydrogen. And now we just simply do our math. So on my calculator, I'm going to take 12 divided by 2 times 2 divided by 2 times 18 gives me a total of 108 grams.
What about that?
So yeah, so this is going to be 108 grams of water. Now that's not necessarily the answer. That's how many cookies we can make, so to speak. But let's see how many cookies we make with 25 grams of oxygen. So now we do this second line. This is a tedious process. We're going to do the same process. We're going to convert grams of oxygen to grams of water. So oxygen weighs 32 grams per 1 mole, 16 plus 16.
We're assuming that you guys are feeling comfortable with canceling out units and putting the grams in the right spot. We're now at 1 mole of O2. Where do we go from here?
The 1 to 2 ratio. So you're going to have 1 mole of oxygen on this side, 2 moles of water up here. And then we're going to go back again, same number actually, 18 grams in 1 mole. And then we get the answer. On my calculator again, 25 divided by 32 times 2 times 18 gives me a total of 28.1 grams of water. So think about this. If I start with 12 grams of hydrogen, I can make 108. If I start with 25 grams of oxygen, I can make 28. Which one wins? Which one's the correct answer? How many cookies can I make? What's the lower number? So what this is we would say this is how many grams of water you can make. But then the question, which is the limiting reactant? The one you ran out of first was the oxygen. So that makes the oxygen the limiting reactant. And then, of course, the other one that's left over is the one in excess.
So that's the long way. Now let me show you the cheaty way.
The cheaty way. There is a cheaty way.
And I have a feeling that most of you will like doing it this way. All right, so here's the cheaty way. In all cases, you have to convert to moles because our equations are written in moles. So I'm going to do the same first step, in this case, as we did in the long way, and I'm gonna go, there's 2.0 grams of hydrogen for every 1 mole of hydrogen. When I divide these two out, it's gonna give me 6 moles of H2. I'm gonna do the exact same thing for the amount of oxygen. I'm gonna go 25.0 grams of oxygen, and here I'm gonna need you on your calculator. We're gonna go, there's 32.0 grams of oxygen for every 1 mole of...
0.78.
Is 0.78? Now, here is the trick. So this is the true number of moles of both hydrogen and oxygen. Here's the cheaty way. What you do is you take both the number of moles and you divide them by your coefficient. So, moles of hydrogen, the coefficient
so 6
is
divided by 2.
2. So
I can do that in my head, that's 3.
that's 3. And 0.78 divided by, well, see the coefficient here is 1. So 0.78 divided by 1, that's gonna give me 0.78. Now here's what's really cool about this.
So 3 and 0.78, I'm gonna say the smaller one wins.
Yeah, so right here, whatever number is smaller, that's your limiting reactant. So once we know this is the limiting reactant, this is what we do the remainder of our problem with.
Or you could actually just say, start with 0.78
And
moles.
actually, I'm glad that you brought that up. So there's no reason to ever go back to the grams if you're doing the rest of your problem. Once we know the number of moles, this is what we're gonna use. So in
you
fact,
would say what? 0.78 moles of oxygen over 1, and then what?
so here's the other thing, we kind of skipped over this at the very beginning. If you guys look at the beginning portion of this, see where it says theoretical yield? So theoretical yield is just a fancy way of saying amount of product. So anytime that we take one of our limiting reactant and we solve for our amount of product, that's called theoretical yield. So in this case right here, we're trying to solve for the amount
theoretical
of
yield.
H2O.
Yeah, and that would be, and we've done this before, so there's gonna be moles of oxygen is 1 mole of oxygen to 2 moles of water, and then there's 18 grams of water in 1 mole of water. I got some cancelizations going on here, and again, if we would divide all that out, we would get whatever our answer was. We could do it again here.
Yeah, why not?
0.78 times 2 times 18, right? Gives me 28, that's what we call it. That equaled 28 grams of water.
Now we call that 28 grams of water since it's an amount of product that we figured it out. Another fancy way of saying is that that's our theoretical yield. So don't get frightened by the word theoretical yield because it really just tells us the amount of product. But here's what you need to be aware of, and you take a look at your notes. In order to solve for the theoretical yield, you must always, always, always start with your limiting reactant.
Right. And as a note, we haven't done problems. These have been gram to gram problems. I could have asked you for the liters of water, and you would do the same thing stoichiometrically that we did. Instead of like using 18 grams per mole, you might have 22.4 liters per mole. Or if you do the molecules, then it'd be 6.02, Avogadro's numbers, times 10 23rd. So it's not that much of a different step. You've done problems like this. This is how you do limiting reactants. It can be tedious, but it's not work. You're gonna have lots of practice.